Geometry Standard 9. Today we're going to learn about the last learning target in our Standard 9 of analyzing transformations. We are going to be able to, when we're done with this, identify a series of transformations to prove or disprove that two figures are congruent or similar. So the transformations were what we studied in LT1 and 2. Reflections, translations, rotations, and dilations. So you're going to be able to prove or identify two of those transformations in one movement, and then determine if they're congruent or similar. So we're going to look at our first one. First, we have to identify which one is the image and which one is the pre-image. So what did we start with and how did it move? So if we look carefully, remember these primes mean the number of movements. So we look up here, this is our pre-image, which is our green one. And then it looked like it moved down to our purple one. And then our double prime, which is our reddish colored here, is our image, our final. So the question is, how does it go from green down to the red by doing the purple in between? So the question is, translate triangle ABC is transformed to be triangle A prime, B prime, C prime. What type of transformation was used? So if I look at it, it hasn't been flipped over, so it can't be reflection. It hasn't been rotated. It's in the same exact orientation. It's pointing the same way. It's not dilated. It's not bigger or enlarged or reduced. So it has only been translated, which means, remember, slide. So translation. Describe how this movement was performed, so the details of it. So I'll take B to B prime. So notice it went to the left 1, and then 1, 2, 3, 4, 5 down. So the translated 1 unit left and 5 units down. So now we have it on the purple. So it says triangle A prime, B prime, C prime is transformed to create A double prime, B double prime, C double prime. What type of transformation was shown? So again, we'll go through our thoughts. It can't be a translation because it's changed the orientation, the way it's pointing. B was pointing this way, now B prime, double prime is pointing this way. Not rotated. Well, it could be. We look at a rotation idea. Don't think that's it. I think you'd be sitting down here at 1, 2, 3, 4, and up here, and I think it'd be more like this idea. Okay, so I don't think it's rotated. Definitely not dilated. It's not enlarged or reduced. So I think it's reflection. Well, let's look at that reflection here. So reflection is just a flip. So it was at -2, 2. Well, I know under reflection, if I look at my rule sheet on page 31, reflection over the y axis would look like the x would change to its opposite, and the y would stay the same. So if we flip that over, it's at -2, changes to 2, and the y stay the same. -4 changes to its opposite, 4, and the y stay the same. -6 changes to 6, and the y stay the same. So it's definitely a reflection. So what do we notice about the coordinates? That the x coordinates became the opposite value. Value. And the y coordinates stayed the same. How differently could you transform it? Well, if I thought about this, not that I could go to the purple, but if I'm going from just the pre-image down to the image, how else could we do? Well, technically, you could reflect it first and then translate it. So if we reflect it first here, so -1 changes to 1, 3. -3 changes to 3, 5. This would be A prime, C prime. B prime would be at 5, 1, 2, 3, 4, 5, 1. So if I connect those, just visually looking at that, I could reflect it over the Y first. So I've done this first. And then I could have, let's go B prime to double B prime. I would have went opposite though. I would have had gone right 1 and then down the 5. So how could we have done it? We could have reflected first. Then translated. One unit right and 5 units down. So what I'm telling you here is if what I put down here in the video is opposite of how you think about it, do realize that there's not always one. Sometimes there's only one way to get to that, but not always. So if you look at this, we're going to look at our learning target. We had to be able to identify 2 transformations, which we did. So as a translation and then a reflection. And then we're going to decide if it's congruent or similar. Congruent, remember, everything's the same side length, same shape, same size, same angles, same everything. Similar, the angles are the same, but the side lengths are proportional. The sizes are different, but the shapes are the same. So this one, of course, is congruent. So we could say triangle ABC is congruent to triangle A double prime, B double prime, and C double prime. Okay, let's look at a couple examples. So I have my lovely triangle go here, and it it moves all the way up here. So I got to think about what kind of movements we could have done. How do we get it there? Really pay attention to the coordinates. That's how I do it. So first of all, I would write, and again, this is just the way I see it. I write down the coordinates so I can visually see it, because if I have my rule page on 31 out, it's easier for me to kind of see exactly mathematically what's happening. I know some of you are really good at just visualizing it. Okay, so those are my originals. They're going to transform, and we're going to make up this movement. I like to see that second movement. Okay, so we're going to think about this and see if we can mathematically get it on top of each other. So if this is H, and this is H double prime, somehow it can't be flipped at first, or maybe it can be. Maybe if we flip it and then we rotate it. Somehow it's got to rotate, but we got to get up in this quadrant first. Or maybe we could put it over the X. So let's look at it. There's a couple ways to do this. The first time I looked at it, I think I see a rotation of 90 degrees counterclockwise. So I see it rotating up this way, if you can visualize it. And so then it's going to be facing opposite of what I want to end up with. So then I'm going to end up reflecting it. But I also think you could rotate it clockwise 90 and then reflect it over the X. So I'm going to show it with the first way I saw it. But if you want to try it the opposite way, go ahead and try it the opposite way and see if it works out for you. So first of all, I'm going to write down the rule. So the rule for rotating 90 degrees clockwise would be that the X stays the same but flipped, and the Y changes to its opposite. So opposite, so that would be at opposite Y, so that would be 6. Opposite -2 would be 2. Opposite -6 would be 6. And then the X's stay the same, just flip-flopped. So there are my new points. So 6, 2 would go here, and that would be G prime. Then we have 2 7, which is H prime, and then 6, 10, way up there, would be I prime. So try your best to draw as straight a line as you can. Notice that looks pretty good, because the last thing I think we're going to do is just a reflection. So first step under A here is we rotated, or rotation, and you have to give the details, of 90 degrees counterclockwise, or if you're a fan of always going clockwise, that's 270 degrees clockwise. Okay, next step, I can just see it now as a reflection. So we'll check the math first. I'm going to erase this because our new rule will be a reflection rule. So this is now our new xy. And reflection over the y means the x changes to its opposite and the y's stay the same, is the rule. Again, if you can't remember that, just look at your rule sheet, quickly look at it. And I only do this just to make sure my math is right. So if we did this right, g double prime should be at the opposite of 6 is -6 and 2. H double prime should be at the opposite of x, -2, 7. And I double prime should be at -6 and 10. So we'll quickly check that. So double G primed would be at -6, 2, which is totally correct. H is at -2, 7, so H double prime is in the right spot. And I double prime should be at -6 and 10, which it is, so I have done the correct movements. And I can prove it mathematically here. So as a reflection over the y-axis. Perfect. And then the last step is just to determine if it's congruent or similar. So I didn't dilate it. So dilation is the only way we're going to get similarity. Notice that it's the exact same shape, it's the exact same size, which means my side lengths are the same, and the exact same angles, which means my shape's exactly the same. So I can say triangle GHI is congruent to triangle G double prime, H double prime, and I double prime. So that's how the first example goes. Let's look at the last one here. So we have a figure called C. We have a figure called C prime. So no, this is my image. This is my pre-image, and this is my image. I like to put points on there. So I'm going to call this A, this one B, this one C, and this one D. You don't have to. I just find it a lot easier to look at. And then I'll do the same thing here, but I'll call these double primes. This will be the second time we move them. So A double prime, D double prime, B double prime down here, and C double prime. Okay, so I'm going to start with just see what are the coordinates of these points. So A is sitting at -1, 2. B is sitting at -1, -2. C is sitting at -1, -1, -2. And D is sitting at 1, 3. So I'm going to do the dilation first. I think it's easier for me to see the dilation first. It's obvious as a dilation. I notice it's an enlargement because it is bigger in size. So I'm going to say with a scale factor of, because remember you have to give the detail, not only just the movement, but what's happening. So if I notice this side length is 2, and this side length is 1, 2, 3, 4, so then I know it was dilated by a scale factor of 2. So the rule is take your normal xy, and you're going to multiply 2 times the x and multiply 2 times the y. So A prime would be at -1, 4. B prime would be at let's back up, -2, 4. B prime should be at -2, -4. C prime would be at 2, -4, and D prime would be at 2, 6. So I'm going to go plot those so I can kind of see where I'm at here. So I have D at 2 and 6. That's D prime. C's at 2, -4. B's at -2, -4. So here's B prime. And A is at -2, 4. Right up here. I'm just going to connect those so I can visually see that. So the good news is it's the exact same size as my image. So I've doubled the pre-image here. So if I look at that, I go through my thought process. It's not flipped around because it's facing the same direction. So the orientation of the figure is the same. It wasn't rotated. It's not turned in a different way. We already done the dilation. So what's left would have to be a translation. So a translation, and we're going to come out with the details. Let's go D to D. D prime to double D prime. So 1, 2, 3, 4, 5 to my right, and 1, 2 would get it on top of the C prime figure. So translation of 5 units right, it looks like, and 2 units down. So we do the actual math to see if I'm right on that. So this is now our new XY. And if I go 5 units right, which means I'm going to affect the X by adding 5, because going to the right is an addition idea, and going down is on the Y, which means I'm subtracting 2 on the Y. So A double prime, if this is right, should be at -2 plus 5 would be 3, and 4 minus 2 would be 2. B double prime, -2 plus 5 is 3. -4 plus 2 is -2. No, sorry. -4 minus 2 is -6. C double prime, 2 plus 5 is 7. -4 minus 2 is -6. And D double prime, 2 plus 5 is 7. 6 minus 2 is 4. So our last step is just to check that's where they're at. So A double prime is 1, 2, 3, 1, 2. Perfect. B double prime's at 3, 1, 2, 3, 4, 5, 6. Perfect. C is at, I can see it says 7 there. And then 1, 2, 3, 4, 5, 6. Perfect. And then 7, 4, 1, 2, 3, 4. So we have identified our 2 movements, which is a dilation of a scale factor of 2, translation of 5 units to the right and 2 down. Last thing to do is just now prove that this is a similarity. And it's a similarity because it can't be congruent. It's not exactly the same. Their sides are proportional, which is the proportion is 2, and they're still the same shape. So I can say, since figure, we'll just call it figure C. It's a trapezoid, but a figure C, and this is your similarity symbol. So take note of that. That's a similarity symbol. Is similar to figure C prime. I hope this video helps. Have a good day.